Ever cranked up the settings on a new game really expecting, super smooth gameplay?
Yeah, and then it just feels sluggish.
Exactly. Like your fancy graphics card is somehow stuck in the mud. Well, you might be surprised it's not always the GPU. Sometimes the real bottleneck is your CPU, uh, struggling to feed the GPU instructions fast enough.
Hmm.
Welcome to the deep dive. Today, we're really zeroing in on that specific issue. The reported higher CPU usage, people often call it driver overhead, that seems to be linked with Intel's Arc graphics cards.
That's right. So if you're maybe thinking about getting an ARC card or you already have one, or maybe you're just curious about how all your PC parts actually work together.
Or don't work together sometimes.
Right. Then this is definitely for you. We've been digging through the info, looking at community discussions, stuff sparked by analyses like the one on chipsandcheese.com, plus general tech reviews, trying to pull out the really important bits.
Okay, so our mission today is pretty clear. We want to break down what driver overhead actually is. Explore why it's become such a talking point, specifically for Intel Arc.
Hmm.
Understand how it might mess with your gaming depending on your CPU.
Crucial point.
And yeah, just unpack what the experts are seeing. So, okay, let's start right there. What is this driver overhead thing fundamentally?
Okay, so fundamentally, rendering graphics, getting that image on your screen, it's a team effort. Your CPU, think of it like the manager, the coordinator.
Yeah.
It figures out what needs to be drawn and sends out the orders.
Right.
The GPU is the specialist, the powerhouse that actually does the drawing based on those orders.
Okay.
The graphics driver is the messenger, the translator sitting between them. Driver overhead is basically the work the CPU has to do inside that driver software.
Oh, okay.
It's preparing the commands, getting them ready, bundling them up. These commands are often called draw calls, and then sending them off to the GPU.
So the CPU is doing all the admin work before the GPU can get creative.
Exactly. That's a good way to put it.
Yeah.
Now, look, some overhead is totally normal. It's necessary. The CPU has to manage things.
Sure.
But if that overhead gets too high, if the CPU is spending too much time just managing the driver and talking to the GPU.
Then it doesn't have enough power left for the game itself, like the AI, the physics.
Precisely. It becomes the bottleneck. Your CPU is maxed out just feeding the GPU. And even if your graphics card could render faster, it's stuck waiting for instructions.
And that's when we feel it, right? The stutters, the inconsistent frame times, gameplay just not feeling smooth.
It's exactly it. Those annoying little hitches and pauses.
Yeah.
Often that's the CPU getting swamped by the driver work. So the big question then becomes, why does Intel Arc seem to have more of this overhead compared to others? There are a few different ideas floating around.
Okay, let's hear them. What are people thinking? What are the main theories?
Well, one pretty prominent theory goes back to Intel's long history with integrated graphics, the graphics built into the CPU.
Oh, GPUs, yeah.
Right. So the thinking is maybe the drivers for these new discrete ARC cards share some DNA, some underlying code or design ideas with those older iGPU drivers.
And why would that be bad?
Because iGPUs work under totally different conditions. They're right next to the CPU. Power saving is often a huge priority. The whole optimization strategy is different. So carrying over some of those design choices might not be ideal for a high-power separate graphics card.
Like, what kind of choices?
Well, one specific thing people point to is how the driver submits those draw calls we mentioned. Reports suggest the ARC drivers might only use, like, 2 CPU threads for this job.
Only 2.
Yeah, which might be fine for an iGPU, but modern CPUs have way more threads. A driver built for discrete GPUs might spread that work out more effectively, using more of the CPU's power. Using just 2 threads could be, a legacy thing that holds things back.
Huh. It's like using a 2-lane road when you've got an 8-lane highway available.
Oh.
Interesting. Okay, what else?
Another angle is the actual hardware communication. How does the CPU physically talk to the ARC GPU? Some suggest maybe that pathway isn't quite as direct or efficient as, say, what NVIDIA or AMD have refined over the years.
So more hoops for the data to jump through.
Potentially, yeah. Requiring more driver management, which
Ah.
means more CPU work. And then, of course, there's just general software stuff. Maybe the driver code itself isn't fully optimized yet.
Right.
Suboptimal bits of code, or maybe the CPU ends up waiting around unnecessarily for the GPU or other things. Stuff that hopefully can be ironed out with driver updates over time.
Okay, that makes sense. Software can always be improved.
Definitely. Then there's another idea. Maybe the ARC GPUs themselves take a fraction longer to process commands once they get them.
Ah, so the GPU's own speed affects the CPU.
Indirectly, yeah. If the GPU is a bit slower to chew through commands, the CPU might spend more time managing the queue, waiting for it. It's complex. And look at resizable BRR.
Right. That feature seems really important for ARC performance.
It really does.
Yeah.
Resizable BRR lets the CPU see the GPU's entire memory at once. The fact that it helps ARC so much suggests the driver might be dealing with really big chunks of data. So if the driver is sending these massive packets, having that super fast, wide open access via rebar becomes critical. Without it, or if the system isn't great at handling those large transfers, the CPU might be working harder.
Gotcha. So the CPU is managing these potentially bigger data chunks, which adds to its workload.
Could be part of the puzzle.
Yeah.
And finally, just the sheer number of draw calls in modern games. Games today ask the GPU to draw tons of little things.
Yeah, detail levels are insane now.
Exactly. And if the driver isn't super efficient at handling that high volume, the CPU gets hammered. It's interesting, actually. Intel's own guides for game developers give advice on optimizing how they send commands, which kind of suggests Intel knows this can be a sensitive point.
So they're aware of the potential CPU load.
Seems like it. And all these points really tie back to that analysis people keep mentioning, the one from chipsandcheese.com.
Right, right. So what was the main takeaway from their analysis that got everyone talking?
Well, looking at the discussions around it, the core finding seems to be pretty consistent. Their analysis apparently showed quite clearly that Intel's drivers just demand more CPU time to get those rendering commands ready compared to, say, AMD's drivers.
More CPU cycles just for prep work?
Exactly. And they identified this as a major factor behind the performance limits people were seeing, especially when you pair ARC with a weaker CPU. Their deep dive likely pointed to specific parts of the driver where things could be, streamlined.
Okay, so we've got a good handle on the why. It seems like a mix of potential legacy code, maybe hardware communication wrinkles, software optimization, and how it handles data. But what does this mean for gamers? Like in actual games, how bad can it get?
Yeah, the impact really varies. It depends heavily on the game and critically the graphics API it uses, like DirectX 11, DirectX 12, Vulkan.
Okay.
The higher overhead tends to bite hardest in older games, particularly those using DirectX X.
Why DX11 specifically?
Yeah. DX11 is just inherently more reliant on the CPU to manage things. The API itself puts more work on the CPU's plate compared to newer ones like DX12 or Vulkan. So if the driver also adds extra CPU work on top of that...
It really piles up.
Exactly. Any existing CPU limitations in a DX11 game get magnified.
Can you give us some concrete examples? Where have people seen this clearly?
Sure. Warhammer 40,000. Space Marine 2 is one people point to. Benchmarks show a pretty stark difference. If you run, say, an ARC B580 and an RTX 4060 with a fast CPU, like a Ryzen 9800X3D, they might be reasonably close.
Yeah.
But swap that fast CPU out for an older one like Ryzen 5 2600. Right. The performance gap widens dramatically. The ARC card's frame rate tanks much harder than the NVIDIA cards.
Wow, okay, so the CPU becomes the clear deciding factor there.
Very much so. We see similar stuff in Rainbow Six Siege, another DX11 game. The MTS difference really depends on that CPU pairing with ARC, and maybe the most dramatic one reported was in War Thunder, also DX11.
What happened there?
Going from that high-end Ryzen 9800X3D down to just a Ryzen 5 5600, which isn't that old. A CPU reportedly caused the ARC B580's performance to drop by something like 39%.
39%?
Yeah.
It's just from the CPU change.
Yeah, almost a 40% hit. That really, really highlights how sensitive ARC can be to the CPU in those DX11 scenarios.
That's huge. Okay, so DX11 is clearly a potential trouble spot.
Sure.
What about the newer APIs, DX12 and Vulkan? Are that safe?
Generally, they're better. DX12 and Vulkan were specifically designed to be more efficient, to let developers talk more directly to the GPU and spread the CPU work out better.
So less CPU bottlenecking built in?
Right. Yeah. But ARC isn't completely off the hook even there.
Yeah.
Some games, even DX12 ones, still show signs of CPU overhead issues with ARC.
Like which ones?
Spider-Man Remastered, for example. Reports mention significant CPU overhead problems on ARC, leading to frame rates that are lower than you might expect, even with decent modern CPUs. The Last of Us Part 1, another DX12 title, similar stories. Hogwarts Legacy 2 people notice a definite sensitivity to the CPU's power when running it on ARC. Frame rates drop noticeably with older processors.
So even with the better APIs, a weaker CPU can still hold back an ARC card more than you'd expect.
It seems so in certain titles. And then you have games like Starfield, which are just demanding across the board, making it harder to isolate just the CPU overhead part, but it's likely a factor there too.
Okay. And what about really old stuff? Like DirectX 9.
Yeah, Intel's even mentioned that performance in some DX9 and DX10 games might not be optimal yet. They're still working on optimizing the drivers for how those really old APIs handle memory.
Yeah.
So it's kind of across the board, but most pronounced in DX11.
If we look at all the benchmark data together, like the tables comparing the Arc B580 and RTX 4060 with different CPUs, what's the big picture?
The big picture is exactly what we've been discussing. You look at the numbers with a high-end CPU, like that 9800X3D, and the B580 and 4060 are often trading blows. Sometimes Arc is even a bit faster.
Right, showing the GPU itself has potential.
Exactly. But then you look at the results with the older Ryzen 5 2600. The picture changes. In many games, the Arc B580's performance drops off much more sharply than the RTX 4060's. That performance gap widens, sometimes quite significantly.
So the percentage difference gets bigger on the weaker CPU.
Precisely. It's clear evidence of that higher CPU dependency, that driver overhead, having a real, measurable impact when the CPU is the limiting factor.
Okay, this is super important. So for anyone listening who's got an ARC card or is thinking about one, the CPU choice isn't just important, it sounds absolutely critical. What kind of CPUs should people be aiming for?
Yeah, that's the key question. The general advice is definitely pair Arc with a relatively modern and capable CPU. You want to minimize that risk of the CPU holding back the GPU.
So what does modern and capable mean in practice?
Well, Intel themselves suggest at least a 10th gen Core i5, i7, or i9, or obviously newer. On the AMD side, you're really looking at Ryzen 3000 series as a minimum, but Ryzen 5000 and especially Ryzen 7000 series are much safer bets, particularly for avoiding bottlenecks.
Right, so for something like that Arc B580 we mentioned, what's a good balanced CPU choice? Not necessarily top of the line, but solid.
Something like an AMD Ryzen 5 7600, or maybe a comparable Intel chip like a Core i5 from the 13th or 14th gen, those should provide enough CPU horsepower to keep the B580 fed pretty well in most situations.
Okay. And you mentioned memory earlier. Does RAM speed matter much here?
There's some suggestion it might help, yeah.
Right.
Faster system memory like DDR5 gives you more bandwidth. That could potentially ease the CPU's job a bit if it's busy shuffling lots of data to the GPU, especially with rebar enabled. Probably not a night and day difference, but maybe a small edge.
Good to know. Now, flip side. Which CPUs should people be wary of? The ones likely to cause problems with ARC?
Based on the data and reports, yeah, definitely older CPUs, say 3 or more years old, and generally the lower tier models within a generation.
Can you name names?
Sure. The ones that keep popping up as potential bottlenecks are things like the AMD Ryzen 5 2600, the Ryzen 5 3600, even the Ryzen 5 5500, which is a bit newer but cut down.
Okay.
Also, the Ryzen 5 5600G, the G models, have integrated graphics and can be a bit weaker than the non-G versions in CPU tasks. On the Intel side, something like a Core i5 9600K might struggle.
And why those specific ones? What makes them struggle more?
It usually comes down to weaker single-core performance, which is still really important for games and drivers, and often smaller cache sizes. Less cache means the CPU has to fetch data from slower main memory more often, which can really amplify that driver overhead problem.
Gotcha. So it really seems like ARC's performance scales much more directly with CPU power than we're used to seeing with AMD or NVIDIA, especially when the CPU is stressed.
That definitely seems to be the case right now, particularly in those CPU-heavy games or DX11 titles. And it's worth repeating, even a fairly decent recent mid-range chip like the standard Ryzen 5 5600 can still limit an Arc B580 in some scenarios.
Wow, that really drives the point home. The CPU choice needs serious consideration. Okay, so putting this in context, AMD and NVIDIA have been doing this discrete GPU thing for ages. How does Intel's current driver situation stack up against their approaches?
Yeah, the historical context is important. AMD, for instance, back in the DirectX 11 days, used a technique often called immediate context. Sometimes that approach could actually be a bit less demanding on weaker CPUs.
Oh, interesting.
NVIDIA, on the other hand, often used a more complex software scheduler in their DX11 drivers. That could sometimes use more CPU resources, but potentially scaled better across multiple CPU cores in older games that weren't great at it themselves.
Okay, different trade-offs.
Right. Now, fast forward to modern APIs like DX12 and Vulkan. Generally, the consensus is NVIDIA's overhead might be slightly higher than AMD's in these APIs, but they often achieve really good performance when the GPU is the main limitation.
And where does Intel fit into that picture now?
Well, the issue seems to be that Intel Arc's overhead, right now, appears particularly high when the CPU is weak or under heavy load, potentially higher than both AMD and NVIDIA in those specific situations, especially DX11 with older CPUs.
So kind of the worst of both worlds in those specific constrained scenarios.
You could argue that, yeah. And really, it comes down to maturity. AMD and NVIDIA have literally decades of experience tuning their drivers for countless games and hardware combinations.
Yeah, they've seen it all.
Pretty much. Their driver stacks are incredibly refined. Intel is, relatively speaking, the new kid on the block in the high-performance, discrete GPU space. So their current situation really just highlights that challenge. They're still playing catch-up in terms of driver efficiency and getting that smooth CPU scaling we expect.
It definitely sounds like Intel knows this is an area they need to work on. What have they actually said or done about it, and what's the outlook? Can this be fixed?
Yeah, to their credit, Intel has publicly acknowledged these performance sensitivities, especially with older CPUs. That's a good first step, admitting there's an issue. They've also mentioned they're expanding their testing, their platform validation to cover more types of CPUs. So they're actively trying to gather more data and understand the problem better.
Okay, so they're investigating. What about fixes? Can driver updates solve this?
That's the million-dollar question, isn't it? Everyone hopes so. Future driver updates should bring improvements. But how much improvement is possible through software alone? That's where there's some debate.
Why? What's the hesitation?
Well, some people speculate that maybe part of the CPU dependency isn't just the driver's software, but might be somewhat baked into the underlying Alchemist GPU architecture itself.
So a hardware limitation.
Potentially. Or at least a characteristic that makes it harder to fully fix with just drivers. We don't know for sure, obviously. But Intel is talking about their next-gen GPUs, Battlemage, Celestial.
Yeah.
And the messaging around those often emphasizes things like improved efficiency and reduced software overhead. That doesn't definitely suggest they see this as a key area for improvement in future hardware designs.
So a longer-term fix with new generations, maybe?
That seems to be part of the plan. So you've got Intel actively looking into it now, which is positive. But there's this uncertainty about how much can be fixed on current cards, and no clear timeline for major breakthroughs. It's probably going to be a mix of ongoing driver tweaks and bigger changes in future GPUs.
Okay, that gives us a good sense of where things stand. So let's try and wrap this deep dive up. What are the absolute key takeaways for listeners?
Okay, takeaway number one. Yes, Intel Arc GPUs can show higher CPU driver overhead than the competition sometimes.
Right.
Takeaway two. This effect is most noticeable when you pair them with older or less powerful CPUs.
Got it.
Takeaway three. This can hurt your performance more significantly in games that already lean heavily on the CPU, like many DirectX 11 titles.
Makes sense.
And the big conclusion, choosing a capable, modern CPU is really important if you want to get the most out of an Intel Arc graphics card and avoid leaving performance on the table.
Absolutely crucial. So connecting that back to you, the listener, if you've got an Arc card now, maybe take a closer look at your CPU specs. See if it might be holding things back in certain games.
Yeah. And if you're thinking about buying an Arc GPU, definitely don't just look at the GPU price in isolation. Factor the cost and capability of the CPU you'll pair it with right into your budget and decision. Understanding this whole CPU-GPU dance with Arc helps you set realistic expectations.
Good advice. And if you want to dig even deeper after this,
Well, you can definitely research benchmarks for the specific games you play, looking for comparisons with different CPUs. Keep an eye on Intel's driver updates, read the release notes. They might mention specific performance improvements.
and that chipsandchoose.com analysis is still out there if you want the really nitty-gritty technical details.
Exactly. Which leads us to maybe one final thought to leave you with. As Intel keeps working on this stuff, refining drivers, bringing out new GPUs like Battlemage, how might this whole balance between relying on the CPU versus the GPU shift? Not just for Intel, but for PC gaming overall. What does that mean for how we should think about building our next gaming rig?
That's a great question. How much CPU power will we really need in the future as GPUs and drivers evolve? Something definitely worth pondering.